Most of the time when two applications need to communicate with each other, this communication is usually in the form of request and response. If these two applications are microservices, then usually one microservice will send a HTTP request to another microservice, and then it will receive a HTTP response. This type of communication is applicable to many use cases, but not to all of them. What if we have a microservice A that needs to communicate a message to multiple other microservices at the same time? The direct request and response communication is no longer convenient in this case. If there are only 3 destination microservices, then maybe we can deal with it. But what if there are dozens of destination microservices that need to receive a message? Or what if microservices that need to receive a message can be added later? And how many of them will be added later, we do not know. In this kind of use cases, for example, the direct HTTP request and response communication between 2 microservices is no longer helpful. In these kind of situations, we can use event-driven architecture. Microservice A that needs to communicate a message to multiple other microservices will publish a message to a message broker component. Microservices that are interested in receiving this message will consume this message from a message broker component as soon as it becomes available there. This model is often called producer and consumer, where microservice A on the left side is a producer and microservices on the right side are consumers. And you might also hear that this model is called publisher and subscriber, where microservice A is a publisher of a message and microservices on the right side are subscribers that are subscribed to receive this message. As soon as publisher publishes a message, all subscribed microservices will receive this message and will be able to process it. This is very scalable and extensible architecture. Microservices are loosely coupled and completely transparent to each other. You can plug in as many receiving microservices as needed. They just need to know what type of message to expect. Now, the message that is being published and consumed can be of different types. It can be a command, it can be an event, or it can be a query. For example, microservice A can receive a message to do something. This message can be thought of as a command. When microservice A is done processing this command, it will publish a new message, which will be an event. And then all microservices that are interested in receiving this event and are subscribed to receive this event, they will receive it and will process it. And because in this architecture, microservices communicate with each other by means of publishing and consuming messages or events, it is called message-driven architecture or event-driven architecture. Now, as you can see, the event-driven architecture is very powerful, but you need to apply it wisely, because it can be very complex, and when a simple request-response communication is needed, then you do not want to overcomplicate your system with event-driven architecture. Another important point to mention about this architecture is that it is asynchronous. When microservice A receives a request to perform a certain operation, it can publish a message to a message broker and respond back to a calling application right away. But even though microservice A did send back a successful response right away, it does not mean that the subscribed microservices have already received and handled event. The publisher microservice is not aware how many subscribing microservices are there, and it does not know how many of them have handled the event. It is not waiting for them to get their job done. And microservices that consume the event, they do not send back a response to a publisher microservice A. If one of the subscribed microservices is down, a publisher microservice will not know about it, although when it comes back again, it will still be able to consume the published event. And this is another advantage of this architecture over the direct request and response communication. In the case of direct request and response communication, if the destination microservice is down, then most likely it will miss the message and it will no longer receive it. In the event-driven architecture, if one of the subscribed microservices is down, it will still be able to consume the event when it comes back online. And this is because an event message is persisted in the message broker. And when the subscribed microservice comes back again, it will consume the event message that it has missed. In this video course, you will learn how to implement event-driven microservices and how to implement each type of messages that I have mentioned in this slide. You will learn how to publish a command message, how to publish an event message once the command is processed, how to handle published events, and how to work with queries as well. And later in this video course, we will talk in greater details about each one of them. Alright, so let's continue.